Alright, so for this question here, as it is, you cannot factorize it. Okay? So you have to convert this 1 here to cos squared A plus sine squared A. Okay, that's the first step. So that will be cos squared A plus, in fact, okay, let me just write it. Okay. Minus 3 sine A times cos A plus cos squared A equal to 0. Right? Then you can have sine squared A minus 3 sine A cos A plus 2 cos squared A equal to 0. Okay. Then from here now, you just have to factorize. Now if you want to factorize it, you go back to the basics. Okay, in terms of algebra, you can say let sine A be x and let cos A be y. Then you can end up having a quadratic equation which is in 2 variables. Okay? In actual fact, that will be the easiest way of approaching the question. So let x be sine A and y be equal to cos A. Once you do that, we'll get x squared minus 3xy plus 2y squared. This is equal to 0. Okay? Now, going back to algebra makes things easier because you are used to factorizing algebraic expressions. Okay? So, to factorize it in trigonometric form can be a bit of a challenge, so you go back to algebra, then it makes things easy. Alright? Now, I'm not here to teach you how to factorize because factorization is not a topic that is supposed to be taught at grade 11 level. We expect you to know all the techniques of factorization. So I have got that, and I have got that. Okay? I just have to worry about those two terms. So obviously x squared is going to be equal to x by x. That's obvious. And then 2y squared has got two possibilities. You can have positive 2y by y, or we can have negative 2y by negative y. Now, because here we have this minus here, it means the second option will be the appropriate one. Okay, so if I want to get that minus 3, I just have to multiply the 2y by x plus this minus y by x. So this question is very easy to factorize. Okay, so I just open my 2 brackets. Alright, this x here, it has to be multiplied by minus 2y. So I can put my minus 2y there. And then the other x, it has to multiply minus y. Okay? So x by x, x squared. X by minus 2y minus 2xy plus minus xy, you get this. Then minus y times minus y, you get that. Are you following? Right? Then we go back to cos now and sine. So this will be sine A. So sine A minus cos A times sine A minus 2 cos A equal to 0. Okay. Now, already I know that I have to create tan there. Okay. So if I equate each binomial to 0, I'll end up getting sine A minus cos A equal to 0, or sine A minus 2 cos A equal to 0. Okay, since we don't have sine squared or cos squared, we can go ahead and have some water. No, it's not a joke. If he is choked, he needs to drink water.
Oh, I got what you said. Oh, okay.
Okay. So this will become sine A equal to cos A. And the other one will become sine A equal to 2 cos A. Then we divide both sides by cos A. So we'll get tan A equal to 1. And that the other one, we divide by cos A. We get tan A equal to 2. Okay. Remember, the objective, can you sit nicely there? Right, remember, we have to find the general solution. Okay, we have to find the general solution. We are not solving for the exact values of A here. It's just the general solution. Okay, please take note of what I did here. It's very important going forward. Right? That's the other question the other day when you create a quadratic equation in one variable. Right? I use factorization. Here we have got a quadratic equation in 2 variables. Okay? This is the key to solving the problem if you didn't manage to do it. Okay, the algebra part. The link between trigonometry and algebra. Okay?
Sir,
Yeah.
you know what? Sir, like.
Okay. If you went on. Okay. I'm going to carry on. I'll ask you tomorrow whether you have started watching or not. I'll ask you whether you have started watching or not. Okay? All the explanation, that everything that you want to ask is there. Yeah, what's the question?
Why did we take sides? Just divide it by cos.
Okay. All right. Up to this point, were you here when I first introduced the general solution?
Yes.
Okay. It's important for you to know that the goal. Hey, sorry, you too. Can you stop that? The goal, whenever you get any trigonometric equation, the first thing that must worry you is to how you are going to simplify the trigonometric equation until you get sine theta equal to A, cos theta equal to A, tan theta equal to A. So any trigonometric equation, you have to simplify it until you have one trigonometric ratio, not 2. If you have 2, then you have to eliminate either both of them or you have to eliminate one. If you have sine and cos and they are not squared, then it means you have to eliminate both of them and introduce what? Tan. Are you following? You see here, you have got sine A, you have got cos A. None of them is squared. We have sine A here, we have got cos A. None of them is squared. Now, we can't carry on when we have got 2 trigonometric ratios in one equation, like this. So the only route that we have to take is to eliminate both of them and introduce tan, because both are related to tan, using this identity here. Tan theta equal to sine theta over cos theta. That's why on the next page I divided both equations on both sides by cos A to create the what? The tan. Now I have one trig equation which is simplified in one trig ratio. One simple equation simplified in one trig ratio. That's the goal. Okay? Everything you do after this, you just use the formula which I told you about in last week. Okay? You've got the formula. So from here, I'll get A equal to shift tan of 1 plus K times 180 where k is an integer. No need to worry about quadrants and all. Everything is catered for here. Everything is catered. So you get a equal to 45 degrees plus k times 180 degrees. Okay? Then this one here, it will be a equal to shift tan of 2 plus k times 180 where k is an integer. What is shift tan of 2? 63.43 degrees plus k times 180 where k is an integer. And then you are done. No stress?
No stress.
Okay. No need to write quadrant 1, quadrant 2, no need. These are the answers. Okay. Okay, Magwas, because you were not here yesterday. You're following?
Yes.
Minimum 50.
50 marks.
Minimum. Minimum.
For this question. No.
Sometimes you can encounter a trigonometric equation, okay, which might have both sine and sine on both sides. Or it can have sine on one side, cos on the other side. Okay? Sometimes you can have tan on one side and tan on the other side. Now, the way you approach questions like that is slightly different. You pay attention. It's slightly different to what we have been doing so far. Some questions may require you to use your knowledge of core ratios. Okay? Some questions may just have to be done using the technique which I'm going to show you now. Okay, so if I look at the first one, we have got sine 2 theta equal to sine theta minus 30 degrees. Alright? Now, if you want to solve this, okay, because we have got sine on the left, sine on the right, we have got on the left, our angle is 2 theta, on the right, our angle is theta minus 30 degrees. The angle on the right hand side will be your reference angle. In this case now, you don't need to use your calculator to say shift sine, shift cos, shift tan. If you've got a case like this, where you've got one trigonometric ratio on either side of the equation. But your reference angle will be the angle on the right hand side. So, I can move straight away from here to my general solution, so this becomes 2 theta. The sine and the sine fall away, and then you end up having theta minus 30 degrees. That's my reference angle. Okay? Then I'll add k times 360 to it. Remember, we are in this case here, if theta is acute, this could be, if theta is more than 30 degrees, then we are in the first quadrant. Right? So we'll get 2 theta equal to, okay, let me take the theta to the other side. So we end up having theta, 2 theta minus theta gives us theta, then minus 30 degrees plus k times 360, where k is an integer. Okay, please take note, this is the reference angle. That's the reference angle, this one here. Take note of that. Right? So I found the first general solution. I need to get the second one. To get the second one, we just have to subtract this reference angle from 180 degrees. Okay? So this will be, remember sine has got 2 general solutions. So you end up having 2 theta is equal to 180 degrees minus theta minus 30 degrees plus k times 360, where k is an integer. Then from here, we'll get 2 theta equal to 150, okay, that will be 210 minus theta plus k times 360, where k is an integer. Well, I think I don't want to go to the next page, so let me just conclude it there. So I take the theta to the left. Okay, for the sake of avoiding confusion, think let me go to the next page. Because I realized that I'm gonna have to divide by 3 on both sides of the equation. Yes, if you check the minus theta to the left, you end up getting 3 theta. Then you have to divide. So I need 2 more steps there. Oh, we have got 10 more minutes. The lesson ends at 1:30, isn't it? Okay, I was thinking about 20 past. Okay. Can I carry on? What? I'm going to do that. Yeah. Okay, so if I go to the next page, I'm going to end up having 3 theta. Is she okay? Okay, please do yourself a favor. If you have got a highlighter, you need to indicate that this is your reference angle. Right? Alright, let's carry on. So we'll end up getting 3 theta is equal to 210 degrees plus k times 360, where k is an integer. Then you divide both sides by 3. You get theta equal to 70 degrees plus k times 120 degrees. Okay, then we are done. Okay, so we're done with that. Now, this is the second general solution. Let's do a quick test. Yes, let's do a quick test. Let's put k equal to 0, or maybe k equal to 1 here. So you get 120 plus 70, which gives you what? 190. Are you following? Yes. Some of you is like you are not hearing. My voice is so loud that you should be able to hear me even if you are sitting at the back. Right? So when k is 1, you have 120 plus 70 gives you 190. So let's go to the original equation. Put 190 here, you get sine 380. Then put 190 here, you end up getting 160. Okay? Sine 380 is in the first quadrant, which is the same as sine 20. And sine 160 is the same as sine 20. So the general solution is perfect. I hope I'm not talking to myself here. Look, in which quadrant is 380 degrees? First quadrant. 380 is the same as 360 plus 20, which is the same as sine 20. Right? Sine 160 is in the second quadrant. Subtract 160 from 180, you get what? 20 degrees. Sine 160 and sine 20 degrees, they are the same. Hey, you have to be sober. You have to be sober. Okay. You have to be sober. Okay. Any question? Okay, let's do another one. I've got 7 minutes then. I thought I had 5 minutes earlier, so I've got 7. Okay. All right. Are you following? Okay. Alright, let's do B. So we have got cos x minus 10 degrees is equal to minus cos 2x plus 15 degrees. Right? Okay, now I just need to explain that for this one now, because we have this minus here, that minus there, it caters for the two quadrants in which cos is negative. Okay? And those two quadrants are the second and the what? And the fourth quadrant. Alright? Okay? So our reference angle is that. Okay? That's our reference angle. Now, this one now, we have to be extremely careful because this minus here, it changes slightly our approach to dealing with the question. So the minus tells us we are either in the second or the what? The third quadrant. Now, if you have got an angle like this, generally we treat it as an acute angle, right?
Yes.
We treat it as an acute angle, right? So, the first general solution will say x minus 10 degrees, which will be equal to. Now, if you want to get the one in the second quadrant, we subtract the reference angle from 180 degrees. If you want to get the angle in the what? Second quadrant. So this will become 180 degrees minus 2x plus 15 degrees, k plus k times 360, where k is an integer. Then you get x minus 10 is equal to 165 minus 2x plus k times 360 degrees. Okay, so we end up getting 3x. What? Are you talking to me or you're talking to me? Yeah, but she must ask me properly. I will answer. Okay, you asked me about this. Okay, I said this question here is a bit different from all the questions we have done so far. So the approach to find the general solution is going to change slightly. Instead of using the normal formula, I can't do that because of this minus. Okay, this minus tells me that the ratio is negative. In which two quadrants is causing negative? Second and what? Third. Second and third. Okay? Your reference angle is 2x plus 15. If you want to get any angle between 90 and 180, you have to subtract this angle here from what? 180 degrees for you to be in the second quadrant. Are you following that? So we are in the second quadrant now. Okay? Then you simplify this. So we end up getting 175 plus k times 360, where k is an integer. Right? Then you divide by 3 throughout. Can someone tell me what is 175 divided by 3? 58, 3. Okay, plus k times 120 degrees, where k is an integer. Okay, I've got 3 minutes. All right. Can someone do a quick check? When k is 0, put x0 at 58,33 there. 58,33. When k is 0. You substitute here, you substitute there. Are you getting the same answer? Huh? You're getting the same answer. Some of you are quiet. Don't be a spectator. Okay, be on the field. Okay? So I've dealt here with the second quadrant, right? Now I need to move on to the third. Right? You carry on. To do the third quadrant, this is just a hint. Where I put a minus in, you put a what? A plus. Okay, then you can carry on. Also, you need to do D. Okay, copy down D before you go. That's your homework. So your homework, you get the second general solution, and also you do D.